Hello and welcome to CCNA 2. This is chapter 6 on VLAN, and in this video I talk about VLAN implementation that is covered in section 6.2. And what is VLAN implementation? Now in this lesson we learned that different Cisco switches support various number of VLANs. The number of supported VLANs is large enough to accommodate the needs of most organizations. For instance, Catalyst 2960, 3560 series switches, they support over 4,000 VLANs. Normal range VLANs on these switches are numbered from 1 to 1005. Now you can find it out if you go to a switch. You just open the command line switch, type show VLAN brief. Okay, so it shows you the default VLANs. Notice that all interfaces are all on default VLAN 1. That's the default VLAN. And then you have the ID 1002 through to 1005. These are reserved for token ring and fiber distributed data interfaces, or FDDI interfaces. These are also default normal range of VLANs. That are typically used in small to medium-sized businesses and enterprise networks. So 1005, again, these are automatically created. They cannot be removed. 1004, 1003, 1002, these cannot be removed. Okay, so you can only use from 1 all the way up to 1001 at least. You can use up to that range. Now, configurations that are stored within a VLAN database file, they are called VLAN. This file is called VLAN.dat, and it's located in the flash memory of the switch. So when we type show VLAN brief, that information that is displayed here, that's taken from that VLAN database file, or the VLAN.dat file. VLAN trunking protocol, which helps manage VLAN configurations between switches, can only LAN and store normal range VLANs. Okay, and these are the type of VLANs. Now there are also extended range VLANs, which you do not normally see here. That's the range that's starting off from 1006 all the way up to 4096. Okay, these extended range VLANs, and they are identified by these IDs, and typically you cannot see them listed when you type the show VLAN brief. And for these configurations, they are not written to the VLAN.dat file, and they support fewer VLAN features than normal range VLANs, and they are of course saved by default in the running config file. And VTP does not LAN extended range VLANs, so that should indicate to us that when you are configuring VLANs, if you are using normal range VLANs, any information you configure about those normal range VLANs, they are typically stored in the VLAN.dat. Any extended range VLANs are stored in the running config. Okay, so if you delete the running config, you would expect that your extended range VLANs configuration information will not be available to you anymore. Now do note that the 4096 is the upper boundary. This is the upper boundary for the number of VLANs available on any Catalyst switch, because there are 12 bits rather in the VLAN ID field of the IEEE 802.1q header. So if you have a look at the header itself, you will notice that this range from range 4096 and beyond does not appear in the VLAN.dat file. The reason simply being that the 12 bits only available in the VLAN ID field. Okay, so it does not appear. Now configuring or rather creating VLANs, again in section 6.1 you would have already seen the importance of what VLANs are and why it is important to create VLANs or configure VLANs. And when you're configuring normal range VLANs, the details again, these are typically stored in flash memory in this file called VLAN.dat in the switch. Now flash memory, we by now should know, is persistent, and it does not require the copy running config or startup config file or command read a command in order for it to store the data. However, because other details are often configured on a Cisco switch at the same time that VLANs are created, it is always good practice to save the running config changes to the startup config. So always important, anytime we make changes to a switch, we should always type a copy run start, meaning we're copying the running config to the startup config. However, when we talk about VLANs, take note that flash memory itself is persistent, meaning even if you don't type copy run start, it still stores that information in the VLAN.dat file. However, it's always good practice. It's always good practice to still go ahead and type copy run start, just to make sure that the information config changes that are made have been changed. Now, as you can see here in this diagram, we have a syntax on when you're configuring VLANs. What are the commands that you need to enter? Well, before you configure VLANs, always important, you have to leave the privileged exec mode, go into the global config mode by typing configure terminal or short config T. That takes you into the global config mode. So you will notice the switch prompt will change. You will have the config in bracket and the hashtag, and then you type VLAN. Now you have to give the VLAN an ID. Okay, so remember that the normal VLAN ranges from 1, well, default is 1, from 2 all the way up. Okay, so of course you can give it VLAN 1, but by default VLAN 1 is already occupied. All interfaces are belonging to VLAN 1. So you give the VLAN a number, and best practice is to always document this information before you go ahead and configure. Okay, so you can see here that switch 1, let's say for example VLAN 20 is to be assigned to students. It's a student VLAN. Okay, so configure terminal VLAN, we give the VLAN ID which is 20, and we give the VLAN a name. Now we specify a unique name to basically identify what this VLAN is. So a number itself does not really help, but if we give a name, that name helps us to identify what particular network this VLAN serves. So we give this a name, student, and then the keyword end basically takes us back to the privileged exec mode. If you just type exit, it takes you out of the VLAN config mode and back into global config mode again. So end, when you type end, it takes you directly back to privileged exec mode. Okay, so the activity that I've uploaded onto NetAcad for you to do, this particular activity, you're going to create VLANs and you're going to also assign ports to those VLANs. Okay, so here notice that we've created a VLAN now, VLAN 20, with the name student. Now the next thing we need to do is remember that by default, all ports belong to VLAN 1, which is the default VLAN. So after creating a VLAN, the next step is to always assign ports to the VLAN. And an access port can belong to only one VLAN at a time. Okay, one exception to this rule is that of a port connected to an IP phone, in which case there are two VLANs associated with the port, one for voice and one for data, which is a standard best practice whenever you have a voice traffic also in your network. So you can see example 1 here. Well, the first table, we have the commands, okay, the syntax for defining a port to be an access port and then assign it to a VLAN. Okay, so by now you should know what an access port is. So here we use the keyword or the command switch port mode access. Now this is optional but strongly recommended as a security best practice. And with this command, the interface changes to permanent access mode. So what we are really doing here in example 1, when we type config terminal interface F0/18, we are specifying that from port 0 all the way to port 18, we want to assign these ports to VLAN 20 and also change the mode to access ports. So these VLANs now these ports become access ports, port 0 to 18 that is, and they belong to VLAN 20. So anytime you connect a device to any one of these ports from 0 to 18, they automatically become part of VLAN 20. So they will not be able to access any other VLANs except VLAN 20, unless otherwise you do configure some trunk ports that will allow multiple interfaces or VLANs to be able to interact. Okay, so in this case, the interface range command can be also used. Well, notice that we did not. Hold on. I made a mistake here. Interface F018. That's interface 18 only, to be more specific. If we had to use specify a range of ports, then we would use the interface range command instead. Okay, so my apologies on that. The first example, the example 1, interface 0/18, that is specific to one single port only. So we are specifying that port 18 belongs to VLAN 20 and it's an access port. If we wanted to specify a range of ports, then we would use interface range, then 018 to, or with dash to whatever port we want to stop at. So in this case, if we wanted to specify all the way up to port 20, then we would use something like interface range 018 then dash 20. So that means from port 18, 19, 20. Or if we wanted to go all the way to port 24, 0/18 dash 24. So that signifies that interfaces ranging from port 18 to port 20 belong to access VLAN 20 and they are an access port, or they become access port. So the switch port access VLAN forces the creation of a VLAN, even if the VLAN does not already exist. Okay, so take note here that when we type VLAN 20, we create a VLAN now and we give it a name student. Now if we had not done this in the first place and we instead go ahead and type config terminal interface range F018-20, we're now specifying that from port 18 to 20 will become switch port mode access, they become access ports. Switch port access VLAN 20, we now force the creation of a VLAN 20 even if we did not create it in the first place. Okay, so that's an important point to take note of. Even if you have not created a VLAN 20, just by using switch port access VLAN 20, you are already creating a VLAN in this case. Now look at example number 2. If I can just zoom a bit closer. Okay, so example number 2, you can see that we have switch 1, switch 3, we have PC5, and then we have an IP phone. Now remember that here we now have two different types of traffic. We have voice traffic as well as data. Now always best practice whenever we are configuring VLANs in a network that is going to carry both voice and data, it is recommended that we separate traffics into two different VLANs. Now you will notice that Cisco always use the number 150 for voice. Okay, so here we have VLAN 20, we give the name student to that VLAN, so that's data VLAN. VLAN 150, name voice, so we are, for voice traffic we are assigning the VLAN 150 for this type of traffic, and we named it VLAN voice. Okay, exit interface port 18, so we now specify port 18 to be part of, because that's what PC5 and the IP phone are connected to. Interface port 18, switch port mode access, so we now specify that port 18 is an access port and assign it to VLAN 20. Now the next thing we should do here is we specify the next VLAN, okay, VLAN 150, to also carry voice traffic, but that also means that port 18 should also be able to carry voice traffic. Now here notice that we add additional commands here. Notice those additional keywords are MLS, okay, quality of service, and trust, okay, COS. Now here basically what we are doing, okay, so the interface port FA018 switch port mode access. These keywords, basically what happens here is the port 18 is placed into VLAN 20. It's made an access port, and the next line, MLS QoS trust class of service. Basically what this LAN, all you have to know by now, at least at this point, on what this MLS does is it places the quality, or it enables quality of service globally. This command line is especially configured every time you're going to use port queuing, specified port queuing mode, when you're setting up VLANs that will allow voice traffic to pass through. So it's all about quality of service and class of service. So MLS QoS basically enables quality of service globally, and then that line of command, you will notice that it's always used when you're specifying, when you're creating VLANs that will carry voice traffic as well. Okay, so notice we enable MLS QoS here, we enable quality of service globally, and then we set the switch port to voice VLAN 150. So port 18 not only carries data traffic, but it can also carry voice traffic as well. Okay, so two things that port 18 can carry. It can carry data traffic as well as voice traffic. Now, the next thing we need to look at is when we are creating VLANs, we can of course assign ports to those VLANs, but also change those ports, meaning that we can remove those ports. So we can. So there are a number of ways to change VLAN port membership. If you have a look at this image here, notice that the syntax for changing a switch port to VLAN 1 membership is with the no switch port access VLAN command. Now this is just the same command where when we remove the no in front, you have switch port access VLAN, and then we assign a VLAN number. Okay, so if we wanted to reverse that process, we just simply put no in front. Okay, so interface F018, we specified the port, and then the next line we remove the VLAN assignment from the port itself, and we return back to the privileged exec mode. Now this is this works when you do not want a particular interface to be used in a given VLAN. Okay, so notice that when we remove the switch port, if you go back to the configuration and you type show VLAN brief, you will notice that VLAN 20 student VLAN no longer has any ports assigned to it. Okay, no active ports. If we go back and type interface F018 switch port access VLAN 20, we will again notice that port 18 will be under VLAN 20 again. Okay, so a port can easily have its VLAN membership change. Again, there are a number of ways to do that. Okay, so one simple method is to use the no switch port access VLAN command. Okay, when VLAN 20 is active, even though there will not be any ports assigned to it. Another way is to change the VLAN membership by assigning that port to another VLAN instead. Okay, so if we go ahead and type interface F18, even though we know that 18 is part of VLAN 20, if we go switch port access VLAN 150, okay, we are now changing that port membership of that port back to another VLAN again. So a port can easily have its VLAN membership change, and it is not necessary to first remove a port from a VLAN to change its VLAN membership. Okay, again, as I've said earlier, when an access port has its VLAN membership reassigned to another existing VLAN, the new VLAN membership simply replaces the previous VLAN membership again, as you can see here. Now another way to remove, not just remove VLANs, is also deleting the VLAN, not just the port, but you can of course delete the VLAN. See, in the example here, the no VLAN and then the VLAN ID command itself is used to remove VLANs from the switch. So we have an example here, the same VLAN, VLAN 20. If we type config T, go no VLAN 20, basically what we are doing here is we are removing the VLAN. So it no longer appears in the VLAN.dat or the VLAN database. So when you type show VLAN brief command, it will verify that VLAN 20 is no longer present in the VLAN.dat file. Now, just a word of caution here. When you are using the before you are deleting a VLAN, you have to reassign all member ports to different VLANs first. Any ports that are not moved to an active VLAN, they are unable to communicate with other hosts after you deleted the VLAN until you assign them to an active VLAN. Okay, so what that means is, take for instance, we were talking about port 18. Now, if port 18 was assigned to VLAN 20, and we went ahead and used the command no VLAN 20 without having to first reassign port 18 to another active VLAN, for example, back to VLAN 1. That means that once we deleted VLAN 20, port 18 will not be able to communicate until we reassign it. Okay, until we reassign this port to another VLAN. Now, notice that alternatively we can of course delete the entire VLAN.dat file using the delete flash VLAN.dat. We can of course use this command to delete the whole entire VLAN.dat file and remove it from its default location. Now, after issuing this command and we reload the switch, the previously configured VLANs, they are no longer present, and this effectively places the switch into its default factory default condition or its factory default settings with regard to the VLAN configurations. Notice that for Catalyst switches, the erase startup config command must accompany the delete VLAN.dat file prior to reloading the switch to its default factory settings. Okay, erase startup config, and then when you type reload, it reloads the whole entire switch back to its default settings. Now, what does this delete VLAN.dat file mean for any existing VLANs? Well, remember that any normal range VLANs config information is always stored in the VLAN.dat. So when we actually delete the VLAN.dat, it deletes that file from its usual location inside the flash, and that eventually removes all VLAN information. So we do not have any existing VLANs anymore in the switch. Okay, so very important point to consider here. Also a word of caution when you are trying to delete VLANs. So it's always best to reassign VLAN ports before you remove a VLAN. But alternatively, you can of course remove the whole entire VLAN.dat file. That does not mean that it will you can't create any more VLANs. No, you can create VLANs. It will just basically create another VLAN.dat file. Now, the last point here is on verifying VLAN information. After you've configured a VLAN, you can always validate or verify VLAN information by using the show commands. Now you can see here that show VLAN or show interface command options can be used to show what VLANs are existing, what ports have been assigned to those VLANs, or even if you type show interfaces, VLAN 20, you can identify what if that VLAN is existing and additional information about that details, especially about that VLAN. Now the show interfaces VLAN and VLAN ID itself command displays details that are beyond the scope of this course. The important information that appears on the second line in this figure that we are trying to look at, especially here in line in figure 3, indicating that VLAN 20 is up. Okay, that's what's important. Okay, that is the basic information that we would be expecting to check when we use show interface VLAN 20. Otherwise, if you're going to look at additional details about the VLAN, then this would be a great command to use. The command show VLAN brief is a sufficient command if we just wanted to see information about the VLAN and what ports have been assigned to the VLAN. But of course you can use show VLAN and type the name of the VLAN, but before that you have to type name first. So show VLAN name student will show us information about VLAN 20, which we have named as the student VLAN. Okay, so this lesson, basically what we have looked at was configure. When you implement in VLANs, you configure VLANs, create the VLANs first, assign the VLAN, assign ports to the VLANs, and then you can now the VLAN can be now active. Now the next thing we looked at was changing port memberships, or VLAN memberships rather. When you remove a VLAN without reassigning the ports to another VLAN, an active VLAN, ports will not be able to communicate. Okay, so we must reassign port membership to active VLANs before we remove VLANs by using the no VLAN command. Okay, and the last thing we looked at was, of course, deleting VLANs. Okay, we can delete VLANs, or alternatively we can delete the VLAN.dat file that effectively removes all VLAN information. Now there's a lesson I've uploaded onto, well, an activity I've uploaded onto NetAcad. Please complete that activity. It's packet tracer on configuring VLANs. This is the activity 6.2.1.7, where you are expected to do several things. Well, three main tasks. You verify VLAN, default VLAN config, configure the VLANs, and part 3, you assign VLANs to the ports. So please complete that activity and submit to the link provided on NetAcad. Okay, in the next video I'll look at trunking. Okay, I'll talk about the IEEE 802.1 trunk links and how we can configure those trunk links. Okay, so briefly, trunk links are important because VLAN to VLAN communication will not happen unless we specify ports to be trunk ports. So for example, in this VLAN here, in this example here, PC1, PC2, PC3 can be able to communicate. Okay, they can be able to communicate, but for this network to communicate with another network on a separate VLAN, it will not be able to work. Okay, so we have to configure these ports as trunk ports so that they can carry VLAN 10, 20, 30 traffic on one particular port. So I'll cover that in the next video.